Okay, I want to talk to you about how to check voltage with the electrical multimeter. We'll take a simple circuit right now. Of course, we have single phase voltage and three phase. Now I'm just talking about a single phase, single circuit with a 120 volts feeding a light or a motor. Now, we need three things to complete a circuit, and that is we need a power source, and I'm naming that L1. That would be a hot wire that feeds 120 volts, and I'm breaking it here with just a simple switch. We need a power source. We need also a load. This could be a light or a motor, anything of the type, something that turns potential energy into kinetic energy. Either it creates a light or turns a fan, such as a motor. And we also need, the third thing is a complete path to ground. Okay? Without that, the circuit won't be complete. So I've drawn here all the components we need. We really don't have to have a control device here. We have a power source, and we have a load and a complete path to ground. Now, when we use your meter to check electricity, you're not really checking electricity. Now, what I mean by that is you're checking, the meter doesn't read electricity or voltage. It reads the difference in voltage. So if you don't have any difference in voltage from one side of your lead to the other compared to the other side of your lead, you won't read anything on your meter. Now that's very important, okay? You also need to understand the difference in what a load is and a non-load. A load is a device that turns potential energy into kinetic energy, such as a light or a motor or a pump. Now, a non-load is a circuit, a device that's put in the circuit, like a switch or a fuse, some type of pressure switch, anything like that. It doesn't use any energy, it just makes and breaks the circuit. So it's important to know whether you have a non-load device or a load that you're checking across. Now, if we have 120 volts right here feeding this circuit, all right, power's coming up here going to ground. Now with the switch closed here in this position, obviously the light would come on if everything is working properly in the circuit and we have a light bulb in it and so forth. Now, if I'm going to put I have two leads on my meter. If I'm going to put one of my leads here in check and one here in check across that switch, okay, just like this, I'm going to read, remember, I'm going to read the difference in energy or in voltage. So if I read 120 volts, if I have 120 volts right here coming in to this side, all right,
it says 20,
and this circuit switches off and the electricity or the current flow is broken, I'm going to have 0 over here. So if I put my meter across this switch, then I'll read 120 minus 0, I'll read 120 volts. All right? Now, if I close this switch at this point and the light is operating, all right, I've just closed my switch. Now I'll put one lead on this side, I'll have 120 coming in, but on the other side, instead of having 0, I'll also have 120 volts here because my switch is closed. So I'm reading 1 point here, 1 point here. So I'm reading 120 volts on both sides. 120 minus 120 is 0. My meter will now read 0 voltage, although I have electricity flowing. Now, on my load device, all right, if the switch is closed, I have 120 volts. If I check on each side of this device here with my leads, this is going to use energy or use electricity and convert it to light or some other type of motion. I'll have 120 coming in here, but since this is a load in my system, this side is going to be 0 because this device is converting that energy into something usable. So now on my load, if it's operating, I'll read 120 here. 120 minus 0 is 120. Okay, so there's a difference in whether you're reading a non-load and a load device. Now, if ever you're going to check a circuit, let's say I had a fuse or something in this circuit here to break if we had too much amperage in the system just as a protection device. Anytime you read and try to get a good reading on your meter, okay, you need to always make sure you have a good source to ground. right here. So I would check, if I want to try to troubleshoot this system here and see where my breakage is, if I have several devices in series with my load, I'd put one lead here and I'd have to have the other lead on a good source to ground. So I would want to map this. I would want to put one lead here in front of this, okay, and read across it. Then I'd go to the other side. I'd leave the common port on my neutral side on my ground. Then I'd come here, here. You always have to have a good source of ground if you're going to troubleshoot electrical systems.
You done?
Done.